Drive it to you, Drew.
Okay, can everyone hear me? Great, okay. Yeah, I'm Drew. I'm going to talk today about knowledge graphs in the wild and some of the difficulties we've had with making them work and getting them to do what we want. So first of all, I want to say thanks to Stockholm AI for having us. Thank you to Armin for organizing. Thank you to the other speakers. It was really cool to see some friendly faces tonight. Let's get started. So today we're going to talk about what is a knowledge graph. I'll go super quickly because we've already covered it extensively and better than I would have. Introductions, what we did, which is quite actually a long section, the main learnings, the final outcomes, some final conclusions, and some time to take some questions. So first of all, what is a knowledge graph? At the end of the day, it's a data structure to connect entities via often typed relationships. So I pulled this off of Google image search. We have someone named Bob, who is a friend of another person named Alice, who is also interested in something called the Mona Lisa. So you can see that we have these entities. They're also called nodes. We have these relationships or edges, depending on how you want to talk about this. These can be a very powerful tool to represent complex and unstructured relationships, especially when you want to think about going perhaps from a node like Alice to the Mona Lisa, which might not be as easy to do in a relational database if you don't know exactly what you're looking for ahead of time. In addition, they are very in vogue right now, I think, and honestly very fun to work with. Why are we talking about them today? The real world is messy, often doesn't easily fit into some of the structured data formats that we're used to working with or have been used to working with in the past. And the real world is a graph. This can be protein chains, this can be social networks, this can be anything. A lot of people are finding very interesting and useful applications structuring their problems as a graph. I'm going to talk a bit about knowledge graphs and LLMs. We've talked a bit about, Lele alluded to this a bit, but the kind of Gen AI revolution a year or two ago has really made what was previously impossible or very difficult or hard to imagine doing well or scalably, very easy all of a sudden. I like to tell people there's the low-hanging fruit has been slammed to the ground in a lot of ways. And I think if you are have internet brain like me, and on your LinkedIn, it's completely oriented towards whatever you're following. I'm seeing a lot of stuff about knowledge graphs. I keep clicking on it, so that's why I see it. But a lot of people are offering lots of tools, and there's lots of articles out there about how a knowledge graph can solve your problem. Just download this package, plug your data in, we'll throw an LLM at it, and you would just have instant success. It's going to be fantastic. But I'm here to tell you that this wasn't exactly our experience, and I'm gonna tell you why. So let's go back to introductions. Who am I? I'm a senior machine learning and AI research engineer here at EQT. I'm on the Motherbrain team. What is EQT? We are a Sweden-based, global investment firm focusing on sustainable growth and innovative value creation. We actually recently celebrated 30 years as a firm. Various arms of EQT invest in companies of all stages, sizes, and industries. And I think really relevant for this discussion, we are spread across 20 offices globally and have around 1,800 current employees. So just kind of keep that in mind. What is Motherbrain? Motherbrain is EQT's in-house data platform that focuses on providing AI-powered investment decision support. I'm going to dive into this in just a little bit more, just a minute. I planned to make this presentation a bit more but I changed it at the last minute because of the technical difficulties. So yeah, essentially Motherbrain's a CRM tool for tracking companies, peoples, and deals. Our colleagues, the deals professionals, are super interested, as Lele explained and Valentin also explained, to evaluate companies and track what might be interested, what might be related or interesting, or kind of a baseline to think about if I'm thinking about a particular company. Sorry. The same with people. This, at the end of the day, one of the things I've really realized working in this industry is it's hugely network-based. A lot of the deals that people find are through WhatsApp groups or lunches or dinners or nightclubs. Like people are talking to people about this work, and often that stuff lives in people's brains. We're trying to pull it into the mother brain, I think. So we consider ourselves a repository for institutional knowledge. And what I'm going to focus on when I say institutional knowledge in this case is like documents. So we have lots of deal decks, which I'll talk about a bit later, expert call transcriptions, industry reports, personal notes, people just write on their laptops, like a lot of different stuff. This lives all over the place. We kind of consider this like highly valuable, and it's kind of our edge, right? We've accumulated this knowledge over 30 years, and if we can like leverage it correctly, we can use it to like not reinvent the wheel. We can, if I'm looking at a particular company, I ideally should be able to find who has also looked at this company, who might be the best person at this company at EQT to talk to me about this company or a similar company or the industry. Same when we're trying to find external advisors who might be really relevant to a project I'm working on. So if we can collect it, this institutional knowledge, if we can collect it, collate it, and surface it, we'll be able to like leverage it to improve the business and kind of get a bit of a flywheel going. But it's an if, right? So, oops. Nice. Much of this knowledge has not been captured. Sorry, guys. Okay. Much of this knowledge has not been captured in the Motherbrain platform. Document data obviously is highly unstructured. Until very recently, it hasn't really been a way to easily pull information out of the documents, so people haven't even bothered to upload them, or it hasn't even been possible to upload them. Kind of as a corollary to that, it's a very like unreasonable to ask somebody to look at a deck and type in every single thing they see into some kind of tool, right? Yeah, again, lots of these documents were generated before Motherbrain as a platform even existed. This platform is 6 or 7 years old, and the firm has been around for 5 times that long. So what we did, roughly, is we built a LLM-powered extraction pipeline for private equity deal decks. We built out a knowledge graph in Neo4j based on the knowledge we extracted. And we built and tested a demo app to show some of our users what we built. And our kind of working hypothesis or central assumptions behind this project was, again, significant institutional knowledge did not yet live in BigQuery. We use BigQuery and can only be found in these decks. Secondly, a knowledge graph could be a powerful way to access this institutional knowledge. So some got concrete potential use cases, really focusing on similar entity retrieval. Lele talked a lot about this. So given an entity A, this could be an organization, it could be a deal, it could be some person you're thinking about. Can we find a way to suggest a similar entity? Could also be an org, could be a deal, could be an advisor, could be another EQT employee. So again, we want to avoid reinventing the wheel when it comes to like developing new internal knowledge. And we want to be able to accelerate information retrieval synthesis when kind of thinking about a new deal. Something we pitched as a potential other like thing we could do with this is relation predictions. Lele talked about this a bit also, but can we predict competitors? Can we predict a sector? Can we predict a potential advisor for given like a target or a seed company or something like that? So the first step is this LLM-powered extraction pipeline that I mentioned. So we scoped down trying to suck up all the documents in the world to private equity deal decks. A deal deck is prepared by a deal team ahead of a deal meeting where a team of EQT employees do a lot of work, a lot of very heavy knowledge work, lots of research to create this kind of knowledge artifact that then is presented to the people who are in charge of the purse strings here to give a no-go on pursuing a deal. Potentially like, do we want to start signing fat checks to pay consultants to do further due diligence in this? Or do we want to sign an even fatter check and buy this company? So they're dense, they're incredibly dense, they're very complex in terms of their structure, and they're often like super long, like 70 or 80 pages, 80-page slides. It's wild to look at. We had a lot of not going to say fun, but some interesting experiences trying to like parse these things, look at these things when we were doing some manual evaluations, because it was like, I can't even read this. How can we ask an LLM to do it? Which is something to think about. So the rough pipeline was we split the PDF docs into individual pages using PyPDF. We extracted the text from each page that was extractable. And then we combined the text and the image of the page itself into a prompt. At the time, this is in like February or March this year. So it was the vision preview that was available at the time. And we asked it to analyze each page and extract the relevant entities and relations of interest. I'm going to talk about those in a bit later. We did extensive analysis of the extraction quality. So we talked about precision and recall, and we kind of also evaluated these metrics in terms of like what entities are we interested in, and what are the relationships between these entities are we interested in. So here's just a couple examples of some slides. These are pulled off of the internet, but we, in some cases, had to deal with logos instead of text, which was wild. And just to get a feel like the variation, like sometimes it was like images, sometimes like charts, graphs, sometimes it's tables. Here we would look at these strings on the left and say, these are companies, these are competitors. We want to be interested in creating a competitor relationship. As Lele again mentioned, you could create competitor relationships between these companies, and also this deck is about a company. So the company in question, the target of the deal would be considered competitors to these companies that are mentioned here. We'd also think about the management team. So here's a typical slide you could see in one of these decks. Here's the managers, or here's like the executives. We got photos, we have names, we have titles, we have a bunch of crazy stuff. But it's really important for us to find these things and create these. We kept calling this like the connective tissue of this graph. Because, for example, if David Young worked at this company, but we also know he worked at 2 other companies, that might inherently link those companies and make them more similar, if we wanted to think about it that way. So after we did that extraction and the evaluation, we built out the knowledge graph. We used dbt, BigQuery, Jupyter Notebooks, and ultimately Neo4j. It involved 3 big steps. One was linking, which was matching these kind of extracted strings I mentioned, like these company names on the left. This is just a string, right? We have a database full of companies that have titles, but we need to find a way to link Malient with the Malient we have in our database, if we have it. We might have 10 Malients in our database. How do we decide which one is the correct one? So that was its own task, challenging, of course. Combining, we wanted to kind of deduplicate and also disambiguate with the known entities in BigQuery. So in the case when we had 10 Malients, that'd be a deduplication task, but we might also have 2 Malients that were of significant interest to us in the BigQuery side that we wanted to choose. Is this Malient A or Malient B that we wanted to decide like connect this particular company to, or this string to. So we also wanted to align the extracted data with the pre-existing structured data. So we had a significant amount of this deal information already existing in our database and structured database. And we wanted to observe the overlap and make sure that everything was like kind of looking good, and kind of figure out in what areas the structured data was supplementing the extracted data and vice versa. And then we also did an enriching step where once we had companies and people we were fairly happy with, we used the additional data, metadata we had in BigQuery to say, okay, well, this company, we have a company, we know it's in Sweden. We know our kind of internal sector we have for it. If we have a person, we know some other companies they worked at. So kind of bringing that stuff in and kind of decorating that as well. At this stage, we also did some significant analysis in terms of incrementality. So what is the additional benefit that this extraction effort has generated for us in terms of like what data existed only in these documents we didn't have in BigQuery, right? So this is kind of measured 2 ways. There was the like how many additional nodes did we get, entities did we get, and how many additional relationships did we get. And we found actually that we had significant incrementality, sometimes like 2 or 3 times as many more relations generated from these decks, but only kind of modest incrementality in terms of the nodes. And I think this actually kind of makes sense because the nodes are often known. We know about a lot of companies, we have a knowledge about a lot of people already, but we don't necessarily know how all the companies and people have all are related to each other in the past. So using these decks as a source of this information was really good. So we were happy to say that our first hypothesis that extracting this information would be good was good. It was good for us. So this is the schema of the final graph. We can talk about the nodes and the entities or the edges we pulled in. So briefly of orgs, we have tags, which is like very similar to what Valentin and Hans discussed with us today. We have deals. We have external person, which is an EQT advisor, an outside expert who advises on a deal. Sector, which is an internal EQT taxonomy and like industry taxonomy. EQT person is a deal team member. Who's worked on this deal? What other deals have they worked on? And country, 144 countries, right? And then edge types. I'm not going to enumerate all of these, but we had a lot. So at the end of the day, we had about 30,000 nodes and about 95,000 edges. And I was so pleased with this schema. It just looked so pretty. I stared at it for hours. At the end of the day, it was great. It was really cool. This is a really fun project. It was, I gotta say, it was nice. Yeah, so after that, we built a demo app, did some user testing, and Cecilia was central to this. Thank you so much for your help. It was amazing working with you. So we focused on the similar entity search. So given a company I'm interested in, imagine I've just heard about a fantastic new company. I want to log into this platform. I'm going to learn everything I can about this company in terms of what has been done, who's worked on similar deals to this company, who has worked at this company before, what are similar companies to this company, right? Similar X search, we called it, right? So we built an app that kind of, within this graph that we've built, takes as an entry node, company A, right? And finds within the neighborhood of 3 or 4 hops from company A, we find the nearest neighbors of like the target node type. So let's say I'm looking at company A and I'm interested in finding potential advisors for a deal on this company. So let's look 4 hops away from company A and find all the advisors that might have advised on a company that was on a deal that was in a tag that was shared with company A, right? We calculated a heuristic-based score of the paths between company A and this advisor, because there can be many, right? It's not just the one I mentioned. It could be dozens, honestly. So we did some scoring to say what is the strength? What's the strength of this connection based on how many paths and the length of these paths and the types of nodes between these paths, between these 2 entities. And so we displayed in the tool this like subgraph with like the most relevant neighbors according to this heuristic. And an additional kind of like user-friendly thing we also added, we passed the subgraph to an LLM, just the schema, or just the nodes and entities, and said like, generate an explanation. Why is this person a good fit for this company? So here's an example of it. I'm sorry I had to do some like heavy anonymization of it, but we can see that in this case, I'm interested in the company ABC Pharmaceuticals. I'm interested in finding an advisor for this. So this one, we found advisor X on the left side in the red circle. And the LM response was advisor X is relevant for this company due to shared tags and sector overlap. Her advisor roles at these other 2 companies indicate like valuable strategic and operational insights. So this is the tool we created. It was Valentin built this. He did an amazing job. It was a family affair. It was super nice. So we did user testing with this. We got some really good feedback. So users definitely appreciated the enhanced explainability offered by the visualizations. This kind of similar entity prediction has been a recurring theme at Motherbrain. We've kind of tried to crack this nut a few different ways. And I think something that has been lacking in the past is this explainability thing, because we typically just provide, given a company, here's a big table of other companies without much explanation. It's the user is left to kind of parse out and decide why it might be relevant and why the results may or may not be good. So having the visualization of this graph coupled with the explanation was a really powerful solution. However, users also asked for more information. The ranking scheme that we used to suggest similarity was opaque, almost even to us, to be honest. And it led to some ambiguity. So the people, they're hard to fool. They're experts in their particular fields. You might have a pharma expert or like an expert in a specific subgenre of pharmacology. You might have a legal software expert. And like these people know these fields deeply. And so if we surface a connection or a series of connections that doesn't quite pass muster with them, like we got called out pretty quickly. So we saw within the sectors and tags especially, there was kind of variable specificity, like, okay, well, pharma is not a strong enough link between these two companies. It's too general, so we need something more. They asked for stuff like business model, what their customers were, deal stage and stuff like that. We were unable to provide that to them in the time we had. So hypothesis 2, like, kind of confirmed, I would say. The main learnings from this project was that like precision is like absolutely king. So in a knowledge graph, any kind of like edges you create that don't exist, that shouldn't exist, will like bring together neighborhoods of this graph that shouldn't be connected. And so if you're going to try to engage in these like similar entity search, you can traverse even like a single like bad link. If you traverse that, you arrive in a neighborhood you shouldn't be in, kind of a bad neighborhood, and you it's not great. Like and for like similar entity retrieval, especially. Well, Zoom's updating again. With these experts, like they immediately they're like, this isn't good enough. This isn't going to work. It's all good. Maybe it's Chrome this time. We're back. Okay, so yeah, for similar entity retrieval, it can be a huge trust buster. And I think that while we're on the topic of similarity, we found that it's an extremely subjective concept, which maybe in hindsight isn't a mind-blowing conclusion to draw, but this concept or like this idea of similarity can change on a per user and per use case basis. So we really struggled to fulfill that for all of our users with the heuristic we created, and we had a hard time envisioning like any kind of solution that would serve all users to their satisfaction at all times. That was like a huge finding for us. I think it's like super hard. And then from a more like practical standpoint, like proof of value is a big thing. So loading up a knowledge graph, learning a new query language, paying for enterprise licensing fees, like these are all additional costs, financial and in terms of tech debt. And they're using this tool, this data structure needs to justify its complexity. So I think for this project, we were unable to justify this complexity. We're unable to like demonstrate with our user feedback, user interviews that like this is such a incredible, like badass solution that we had to double down. We had to do it. I'll get into this a bit more later, but yeah. And then I think the golden data set thing is that's a huge thing that is underrated. I think in terms of like the AI revolution that's happened over the last couple of years, I think there's been a lot of excitement for it. I think reality is setting in for a lot of people these days that these things can't do everything correctly all the time. In a setting like this one, in this industry, we have a super high demand for precision, especially as we move more towards like black boxy solutions, right? So as we build these things and evaluate them, kind of going back to the old school methods where like you need a golden data set and able to really evaluate your tools. How good is this? Like what is this good? And I think that in this case, at least, it's very expensive to curate something like that. We were kind of trying to iterate with user interviews, doing qualitative research, which is extremely informative, but it was unrealistic to do qualitative research every time we did a tweak to this model or tweak some component of the pipeline. But that said, yeah, it's better to do this once. We need to think about, is it possible to invest that time to create that golden data set so that you don't have to like engage in like longer form, more complicated, more expensive ways of evaluation. So the final outcome for this project, we like killed it. We paused this project for the time being. We are no longer working on knowledge graphs, at least not right now. But I think the phoenix that arose in the ashes of this project was we were very excited about the knowledge extraction component. So we saw huge gains from that, and we're continuing to explore this in a lot of different ways right now in Motherbrain. Like, given a document and a set of things you want to know about from this document, can we have an LLM pull out this information in a structured way and put it into a structured database? And the answer is like yes, and we now have a lot more knowledge about how to do it. So just to reiterate, these final conclusions, if I want you to leave here tonight to think about something, if you want to try out a KG in production, like you think about these things, what problem are you trying to solve? Do you have the data? Do you have it now? Are you going to be able to get it on an ongoing basis? How hard is it to get it? What does good mean, good enough mean in your context? How do you measure it? How do you evaluate this? What's the evaluation strategy? Is it ongoing? How can you make this happen? Again, how hard would it be to create a golden data set for this task? And then also, like more fundamentally, do you need a knowledge graph for this project? Do any incremental performance gains justify the additional costs? What are some simpler approaches you can try instead? So like we've had projects in the past where like we wanted to do very, very exciting things. We wanted to do modeling, we wanted to do some crazy stuff, but we found out that just writing some clever SQL queries could be like cover 95% of the use cases, and so we went with that. RAG approach has been mentioned again already tonight, like very kind of graphy, but I think easier to work with in some ways, easier to think about. And at any rate, these kind of baseline, simpler approaches like should absolutely be attempted in order to, again, kind of provide the decision about whether it's worth it to really invest in a knowledge graph, right? So like, I've done the SQL, I tried RAG, it didn't work, we need to evaluate this. Yeah, otherwise just go with the baseline. It should be that simple. So not to say don't try this, but be very deliberate about your process and very serious with yourself. This is a fun, very cool thing to work on. I had a blast working on it, but I think that realistically, yeah, it didn't work. So yeah, that's it. Thanks everybody. Yeah.
Yep, we have a first question, Drew. Straight away, mate. Right into it. Yeah.
Did you try at the very end, once you'd come up with that really pretty nice graph, to do a final evaluation step, pulling out the source information of all those entities and having an evaluation done on the source rather than the schema of the result?
I don't understand the question, I'm sorry.
So all the nodes that were there, like the people and the companies and all those things, I mean, you had a lot of source information about them. You had descriptions, you had sort of their CVs, all that stuff, like source documents. Did you try pulling all those source documents into a context and then making an evaluation with the LLM on, is this actually relevant?
No, we didn't. Unfortunately, yeah.
That could be pretty good. Probably.
Absolutely, yeah, I think so, for sure.
I think one thing to clarify is that like this was earlier days, and Context windows were smaller and the models were also a bit older. So maybe if you rerun this again with a larger context window, maybe it'll
Fire up again, put it into O1, maybe it'll work.
Yeah, why not? Yeah.
Any other questions? Yep. Ooh, this is close, but I'll go with you first.
Thank you. I was interested in your comment about subjectivity. You said that it was subjective what two nodes should be far apart or close together, right? Depending on the user. That seems like a fundamental problem which is beyond knowledge graph, right? If your users disagree on that, how do you even begin to solve that?
I mean, you're absolutely right. So I think that the issue is, as you said, like what is similar, and if someone doesn't trust any kind of like similarity method, like what are you going to do? But I think that, you know, if I were to like explore this further, I think I was going to caution against like doubling down on knowledge graphs, tripling down on LM assisted knowledge graphs. But that said, if I was going to do this, and maybe if I do this in my free time and not have to answer to my boss why I keep working on this, I would say that having the user be able to interact with this and say, this is actually what I'm looking for. Like, you showed me this, it wasn't quite good enough, I'm actually looking for this, and kind of have a bit of a chat with the graph and with the results, I think could be a really, really powerful solution, so that you can then, like, again, like, allow the user to bring their own definition of similar on that day for that project to it, instead of trying to guess what it is or make a one-size-fits-all solution.
All right, yeah, thanks for a very useful presentation. I have one question. I'm just trying to understand it. In your experience, what kind of use case will sort of justify building a knowledge graph or a graph rag? Because I think we looked at, there was a code that was published by Microsoft, and I think they were more talking about, okay, you know, it should be able to bring up, because vector search is just when if you find a competitor analysis or if there's a summary of the document done and the user is prompting it, it can, you know, do a vector search and bring the document. But the way they were trying to sell it was that, okay, you know, if you're looking for like a summary of the document, or you're trying to extract some information as in a relation or underlying factual things, I mean, then that's where the knowledge graph is useful. So I'm just trying to understand from you that in your experience, what Microsoft was talking about in that, I don't know if you looked at that research paper, and then afterwards they also published the code. Does it sort of resonate with what you did? Or, I mean, in your case, I mean, in summary, what is that use case where you would go for knowledge graph? Is it building a summary of the document, or is it doing some comparative analysis between two products, or what is that use case?
That's a hard question to answer, because I felt like this was a slam dunk use case. You have this kind of heterogeneous graph, you have mixed entity types, you have potentially like, you know, you have an unknown number of hops between the thing you're looking at and the thing you're looking for. And you want to not only find that, but also again, like explain why it might be a really useful connection. Like, this to me felt like a slam dunk use case. So I don't know what could be like a better one than this one, honestly. I'd be interested to hear if anyone else has any ideas.
I think like I can add to it. I mean, you actually answered it kind of before, which is it's dependent on what your what do you call it, performance or your metrics are. So in this case, it was very high precision mixed with this subjectivity, which is inherent in our industry actually. So yeah, so I think. Yeah, I think it's like, it's not necessarily a use case. It's more of like, what is the actual metric that you're measuring for? So that's you know.
That's a good point. Thanks.
Any other questions? Bill?
Thank you for a very nice presentation. I worked in a very similar use case in about the same time span last year. And I found that PDF parsing was one of the major hurdles to overcome, because it was just horrible. Can you expand a bit more on any learnings you have from the extraction phase of this project?
Absolutely. So you're absolutely right. PDF parsing is horrible. And I showed you some sample slides. The ones we were dealing with in reality were like crazier. They were like ultra dense, super colorful, charts flying back and forth. Like it was wild. So I think that if you're smart about exactly what you want to pull out, you can do it. So we had a large list of entity types and relation types we wanted to pull out, and we actually noticed that the precision was like totally crap for some of them, and we actually tossed them out when building this demo because it was like, this isn't good enough. But in terms of like finding, like, it depends on what you're looking for, obviously, right? If you're looking for text, whatever, but you can also imagine kind of a bit more of a pipeline where like you can train a model or find some model that can like identify, I'm only looking for like blocks of text, or I'm looking for charts specifically. And I know that there are models that are very good at reading charts, right? So maybe you can do some bounding box location, find the chart and pass it to something else, parse that from the other model and put it back in your, there are maybe more like stacked solutions available, but like this like one-shot thing, it can be very difficult, absolutely.
Yeah, no, that was my experience as well. And I mean, it came to the point I felt like, you know, a good PDF parser would be the next tech unicorn.
Yeah, and it was, well, like, absolutely. We had a hack week, was it last year or the year before, where we were specifically looking at like logo extraction. So, right, we were like, what is this logo? Let's pull it out, and how hard could it be to identify what company this is? And first of all, it's nearly impossible. And we had a lot of fun working on that, and it was wild because the very next week, the vision model dropped. So all the stuff we worked on, training little like boundary box detectors, crazy API calls to what is this logo, like reverse image search, all this stuff, not solved, but like was taken care of to some degree. Like the next week, it was quite an experience, I would say.
Any other questions? Oh, you were blind spot.
I was wondering, I didn't quite understand what that golden data set would look like. So if you had infinite time to create a golden data set.
Absolutely. I mean, it's hard, like, especially the more abstract the task becomes, the harder it is to create that golden data set, right? So you can imagine, I think, you know, what they discussed where we know that some of these companies are similar. We've done some manual curation where we looked in these decks and we found like these two companies co-appear. We know they're similar. We've seen this, we confirm this. We can put that in. So you can imagine doing that, or again, like talking to people and just like at EQT, we have like hundreds of deep experts in their fields. So you can imagine that you have to tailor the data set for the task. And that's one of the challenges, because if you want to create something that has like more general applicability, you have to create multiple data sets, and that can be extremely expensive. So I think things have kind of come full circle. I think some of the stuff I mentioned about tech investment, golden data set evaluation are things that we as practitioners have always dealt with, then we kind of forgot about for about a year, and then are kind of dealing with this reality again.
Okay.
Does that answer your question, or?
Yeah, I think so. So what you're saying is, for an application, you have to think about what that golden data set for that specific application is, and then
Possibly, yeah.
Okay.
Maybe that sounds like a bit of a tautology, but yeah.
Cool. Then I think maybe we should end it here, and thank Drew. Yeah, so you can, we'll close it down, but you know, feel free to hang around a bit and talk to speakers and everybody else here. So thank you all for coming. Hope you had a good time and learned a few things. And yeah, we'll have another one in a few weeks' time. So thank you.